Alright guys, this video is gonna be faster, cause who actually sits down and watches 30 minutes of this stuff? And this was supposed to be just like a quick overview of the lesson, but it takes 30 minutes and it takes a lot of my time. So, if you want them all to be 30 minutes, comment down below. But, you know. Alright. This week in a nutshell. Okay, so we learned mostly about arcs, and then we learned the equation of a circle. So this is gonna be actually, this is gonna, I'm gonna try for 10-15 minutes at most. Alright, okay, so essential angle. That's one of the things we learned. Let me draw a picture. This is Monday's lesson. Woo! So it's an angle whose vertex is the radius. And not the center of the circle, and the sides are the radii. That's essential angle. You see? And then, but then the arc intercepted right here is the minor arc, which lies in the interior of the angle. So, and these are the endpoints of this arc here. So, minor arcs. Let's talk about those. They measure between 0 and 180 degrees. They're right here. They're so the correct word is intercepted by the essential arc. So if you're talking about angles and arcs, the arc is intercepted by the angle. And then the major arc is the stuff on the outside. It's like this thing. And they're located on the exterior of the central angle, you see right here. Okay, let me label these. A, B. So this is how we do it. So this is an arc AB, right? So that would be arc AB. Okay, arc AB. But we can't call this arc AB because that'll be too confusing. So usually there'll be another point, like arc C, and then it'll be like A, C, B. You see? A, C, B. That's the major arc. And the major arc is at least 180 degrees. But it has to be less than 360 because circles are 360 degrees. So remember, minor arcs, 2 letters. Major arcs, more than 2 letters. Oh, here's a definition. But the minor of a minor arc is equal to the measure of the central angle that intercepts the minor arc. So say this is like 40 degrees. And this would also be 40 degrees because arcs also has degrees. And then congruent arcs are arcs that have the same measure. Wow. Oh yeah, you see that I'm not writing everything out because I want this to be fast because I have a lot of things to do. And if you want me to make an extended video, I will. Just comment down below. If you want it. And yeah, because if you honestly weren't here, then you'll probably just come back and Miss Fuji will give you all the nuts. So that's okay. So congruent arcs are arcs with the same measure. Alright. And then the arc addition postulate. The measure of arcs of an arc is formed by 2 adjacent arcs that are the sum of the measure of the 2 arcs. So it's basically like the angle addition postulate. And to show, so you know how it's like angle, this is O, angle O, right? And then to make it the measure of angle O is M, right? The measure. It's just same thing. And then it's just like addition and stuff. And then equals that's not right, but you know. In this context, it wouldn't be right. But who cares? That's pretty much it. You can have. So yeah, that's that. And then we have inscribed angles. So let's choose this lesson. Wow, this is going fast. It's an angle formed by two chords, and these two chords have a common endpoint. You see? The congruent inscribed angle theorem. Okay, there's three theorems that came with this. If two inscribed angles intersect at the same arc, then the inscribed angles are congruent. So say you have this, right? And then we had another one here. Then these two inscribed angles would be congruent because they intercept this same arc. The inscribed angle theorem. Okay, I'm going really fast. If an angle is an inscribed angle, then its measure is 1/2 of the intercepted arc. So say this intercepted arc is 40, and this would be 20, and this would be 20. Pretty much it. And then just like a third one, it's not really a theorem. It's just we wrote it like a theorem, but I don't even know. So if an angle intersects the endpoints of a diameter, then the inscribed angle is a right angle. Oh, that's actually a theorem. It's important. So, like, you have a circle, you have a diameter, we have this endpoint, these two chords. So that means this is a right angle. Very messy drawing, but it works. Oh yeah. Now it's the diameter. Alright. So, and then now here we get to this part. I think I'm going to show you how to derive this formula. Okay, say this is a circle formula, or I'm not sure what it's called. Okay, say this is the center, which is not, because it's a poorly drawn circle, and it's h over k. This is the radius r, and that's the distance between h comma k and x comma y. So let's put this into the equation. Distance formula is that's the distance formula, right? And then we just substitute everything in. Next thing, why is there a square? I'm sorry, I'm confusing myself here. You substitute and then you square both sides. Wowzers. And then you get the circle formula. Or, I don't know what it's called. Circle, I think it's circle formula. This is the circle formula. So where h and k would be the x and y coordinates for the center, and x and y would be like a point on the circle, and r is the radius. And then if you're given the equation of the circle, you can graph the circle by making a table. I have no idea how to do that, or identifying its center or radius. So the way we identify is like opposite h, opposite k, right? H comma k, and the radius would be 2. Oh, I don't have graph paper. Alright, found graph paper. So we had this really small one. So h and k is 0. So there would be the center. And then r was 1. And then you just plot all these ones, like this one away, this one away, this one away, this one away. You just draw it using a compass, but I don't have a compass right now. So, yeah. Okay, let me show you how to solve. Okay, so there's gonna be like 3 different situations that might be brought up. Like, So we have the circle formula here. And you're looking for the radius, but you only have this equation and all the stuff is inputted in, right? So looking for the radius, it would be like, so say we had like x minus 1 squared plus y squared equals 10, right? So all you have to do is return it to the standard form, which would be x minus 1 squared plus y minus 0 squared, which equals square root of 10 squared. So basically you do that. So then you know the center is 1, 0, and the radius is root 10. And then there will be other instances where they'll be giving you the center. Center's 0, 0, right? And then like they'll give you a point on the circle, like 1, 1. And you have to do a lot of FSA for this. You just input them in the, and then you get pretty much root 2 equals, and then you input it into the equation. And other times they'll be like, they'll give you the endpoints of the diameter, and you use the midpoint formula to find the center find the center of the circle using the endpoints of the diameter, and then you basically just do this again, and then you write the equation. And yeah, that's pretty much it. Oh yeah, for graphing, if the radius is not a whole number, don't graph it. Alright, end of the video. That was fast. Wow. Oh yeah, Wednesday and Friday we did the NWEA test, the computer test where it gets harder each question, harder or easier depending on how you do. But anyways, this is the end of the video. If you like the length of this if you like these videos being shorter, please tell me. If you don't, please also tell me. That's it. All right. Bye-bye.